Welcome to Build with Naz. In today's live coding video, we're going to cover error handling in Rust using a crate called miette, which is really awesome. We're also going to use a crate called thiserror, which is compatible with miette, but most of the things we're going to be doing are going to be tied to miette. So I'll walk you through. I'll create some examples of this easiest way to use miette, and then slightly more sophisticated examples, and then actually show real code where error handling is used in non-trivial cases, like in asynchronous code with all kinds of complicated event loops and so on. So before we begin, let's start with what an error is in Rust, just to level set. So an error is just a trait, and as you can see, it has a couple of methods, most of which are actually deprecated. The one that's currently not deprecated is source, and if you notice, error is derived from two other traits, the debug trait and the display trait. So the debug trait is meant to be information, like let's say when you implement the error trait for a struct that you create, you can provide you have to provide a debug implementation and a display implementation. What that means is that your struct that implements the error trait, when it implements the debug trait, it has to provide a way to format information from that struct to an operator, so that if, let's say, the error is reported via tracing or some other mechanism, it allows people who are maintaining the code base to have a lot of insight into how they might fix it. The display trait, on the other hand, is meant to be for close to end users, so it's not really information that you would provide an operator, but it's supposed to be something human readable. So yeah, that's the intention behind this error trait. So, and the source is a way to attach an underlying error or anything else. It's actually an example in the source code where there's a struct called super error, which has a source called some other struct, and then essentially to create that error, you basically have to create that struct and then give it a source. So notice that whenever we involve the error trait, invariably the result enum will be pulled in, because that's the convention for error handling in Rust. If a function returns a result, that means that a result is an enum which can have one of two variants. The OK variant signals that the result of that function is good, everything went well, and error, the error variant ERR, means that something went wrong, and that's the error. A lot of times you'll see in Rust code something like a box din error. So this is the error in that din error, and something like typically the result, this is the thing that will be a din error, which just means that in this result will return an error, and there's type erasure in that generic, which just means that anything that implements the error trait will be essentially that error type. And because an error trait, when you implement it, we don't know the size of the struct that implements it. That's why it has to be boxed. That's why you see box, din, or din, and then error. So that's roughly what the relationship between error and result is. And please go read up on all this. There's lots of great detailed documentation on this. This is just like a primer. It's more like a refresher, because we're going to be delving into how to use this more effectively. Okay. So given that error is a trait, we can create an implementation of this trait in whatever struct we write, and that might become tedious because you have to implement debug, which has a bunch dysfunction, the format function, and also display. So instead, there's this library called thiserror, which makes it trivial to use a derive macro to essentially take whatever enum you have that represents an error, and they will automatically generate the debug and display traits as if you've done it by hand. And the way you you guide it is that you have to give for each variant, you have to give it this a bit of extra information. You can think of it as like on an annotation or metadata to help it generate the actual implementations for the debug and the display trait. So there's something called hash error, and that essentially, and we'll see examples of this in the code, so I won't spend too much time on this. But this is a way to basically tell this error for this particular error variant what the debug implementation should be, and so basically return this data for key, and it's got very powerful formatters so that you can basically do all kinds of interesting things with essentially the variants and the structure, like the fields that are in these variants. You can basically format them trivially using this expression. So, and then there's another thing it does, which is it has hashtag from, and I'll give an example of this very soon. This actually allows errors to be of other types to be converted into this particular error. So it makes it very easy to take one error type and then essentially consume it and turn it into this error type. And then, yeah, so, and this is again without writing a lot of, you don't have to write any of this by hand. If you're curious about this, check out this documentation. So for example, the display implementation is generated. So basically when you do this hash error thing, that just implements the display trait for that variant, and then these are all these formatters that you can use to create really nice display messages. And you can even and there's that from thing where a from implementation is generated for each variant containing a from attribute. So this is really handy. And there's a whole bunch of other stuff you could do. So this is this error crate, which is used, it works really well with miette. Miette also works with anyhow. And miette, in a nutshell, is what we're going to be using. Something called fancy mode. And miette actually has, its quote-unquote magic happens using this diagnostic trait. And the diagnostic trait, as you can see, extends the error trait. And it adds quite a few things to the error trait. Things like the source code, the line where things went sideways, like this kind of stuff. It even allows you to provide context. It allows you to chain events, which is really nice. And let's see what else. And it also provides this really pretty report formatter. So like if your program crashes and your main function returns a miette result, then it'll be printed to the screen. This way. This is if you enable fancy, which we will in our code examples in a minute. And then let's see what else. And also the miette result is a drop-in replacement for the standard libraries result. So we'll use that. We'll also see how to use the miette macro, and even provide our own report formatter. It's a global report formatter that we can use. So yeah, I recommend to do a deep dive on miette. Just check out the great documentation. It's really good. But in the code examples that we're going to be going through writing, all of this will be covered. So with that said, let us begin by, oh, by the way, this is what the miette output looks like. I have this project, tcp-api-server. It's on GitHub. I'll put a link to this in the description below. Actually, we'll look at some source code examples of real-world usage of errors and error handling in this project at the end of this video. But yeah, you can see here that I tried to run this process called tcp-api-server, and then I told it to get into debug mode, and I told it to be a client or something. So it's a TCP-API client. I'm assuming it's trying to connect to a server, and that failed. So as you can see, it reports could not connect to the server at port 3000. Are you sure it's up? And the reason, this little red arrow thing, it says connection refused. So this is that pretty formatter. And then if you believe this is a bug, please report it here. So that's I'll show you how to do this. This is creating a custom or global custom report handler for miette. So all this is provided by miette. So that's kind of cool. This part is miette. So that said, let's create a new, let's see. So I just created a new crate called error miette, and let us add some dependencies to it right away. So one dependency I want to add is this. And actually, I don't think we're going to be using Tokyo tracing, so I think this is good. Let's see, here we can see that's this error. And then we have miette with that fancy features thing, and pretty assertions. Pretty assertions is just it's just a way to basically load different matchers for tests so that it looks pretty. And then there's another thing I want to do is I want to bring in cross term, because this is pretty terminal output, because some of the print lines that I'm going to be generating will have color in them. So this makes it so that you can use ANSI escape sequences or colorized output, so it looks good. So with that, let us let's see. Let's go to the librs and let's just get started. So we will not use this function, but let's make a new. Let's do this. Let's make a new module. So we'll say this is basically we're going to do simple miette usage. So this is nothing fancy. Like we're not going to use we're not going to have a custom this thing. We're not going to have an implementation of the diagnostic trait or anything. We're not going to do anything fancy with this error. Just kind of like pretty fundamental stuff. We're just going to be like, all right, let's make a module to see how I can very quickly use miette as a drop-in replacement for, let's say, like a normal result. So let's see, let's pull in a bunch of dependencies that we're going to need right away, and we're going to need, this is for cross-term pretty printing output, and this is the miette into diagnostic, and we'll see the use of into diagnostic in a minute. It's a thing that's used to essentially provide compatibility or transformation between miette and the standard libraries result, which makes it very easy to use miette. So let's make a function. So let's say this function will return an error. So let's just have it return a like a normal result. So this is standard. Where is the standard libraries result? 1 second. Let's see, because I'm gonna pull in the other one as well. Let's see. Where are we? Oh, just std result. So because I mean this is redundant, but let's do this standard result, and then we will need, actually I don't think we need, this is the standard result. Okay, and then so the result needs two types. One is the OK variant, and the other one is the error variant. In this case, the OK variant will be a U32, and it's just gonna, all we're gonna do is parse a number, and we're gonna parse a float into an int, and that will generate a parseInt error. So here we can say, let's see, we're gonna do 1.2, and we're gonna parse that as a U32, and then, I mean, this is basically that's it, and that should, yeah. So what this does is that this expression is generating a result, and if all went well, it will return a U32, and if there was a problem with parsing, it will return, this is the type of the error variant we're going to see, and obviously this is going to be a problem because we're parsing a float as a U32, so that's why it will return an error every time. So that's our little setup, so that we can see a bunch of errors that we're going to manipulate soon. And then let's see, let's make another. This is a bit of groundwork. Let's do this. We're gonna do, this is like how we can use this error. So I'm gonna make an underline database error, and we're gonna say database corrupted. And so this is just an enum, and then using this derive macro, I'm gonna, with this error, I am going to essentially tell it to become a, I'm gonna tell this error to take this enum and implement the error trait for it, like that. And then I'm gonna give it some annotations. I'm gonna say error, and the database is corrupted. So there you go. That's just, we're going to be using this in a moment. So now let's make a test. Let's see, this one is going to be, and that's a test module, and then we can do something like, let's see, we're going to do a test. We're going to say into diagnostic. So I'm going to take this function that returns a regular result which contains an error, and I'm going to say turn it into a miette result. So, and so this is basically how we can, when I make a top level function to return a miette result, this is essentially when this test fails or something, it'll use we'll see like really pretty error output happen because of doing this. And this is returning a unit type because we're actually not going to be returning anything. This is just to essentially see how we can use miette. So this could be like a main function. That's kind of like the intention with this example. So we know that this function return error result, we know that it returns an error, so we can assert that it is an error, and then we should be able to run this test. And there we go. So it goes, yes, it is an error. So if let's say we do something like this, let's see, this is going to fail because this is saying that the question mark operator basically unwraps the error. Unwrap, I mean, it looks at the result, and if that result is an OK variant, then on the left hand side you're going to get the let's say the U32, but because you know the result is that the OK variant is U32 and the error variant is this thing, %error. But if this fails, then the question mark will essentially return. It will return the error variant. So this line will not proceed any further if there's an error. So here it's complaining. It's saying blah blah something something miette diagnostic something something something. So what this is saying is that the function the header says that it returns a miette result, but this is not a miette result. This is something else. This is like a regular result. And so here what we can do, and this is kind of like almost like muscle memory at some point, you can just call into diagnostic, and this is basically how this result gets transformed into something by miette that implements a diagnostic trait which satisfies this type, the result type. So the miette result type is actually just, there's the core result type and there's a T and an E. The E in this case is a report, and the report is actually a struct. So this is how sort of almost all the errors with miette are handled. So you pretty much have like miette result instead of result, and wherever you're going to call, wherever you're dealing with a result, if you have a question mark operator, you just call into diagnostic and then question mark. That's roughly how this works. So it's kind of like pretty clean way of handling this. And if I run this, you will see I get a nice error message saying, with a little X, the red X and everything. Miette is doing all this, by the way. And it goes, there was an error and invalid digit found in string, which is exactly right. So this happened because I said error result and then question mark. And then because we have miette result as the return type for this function, I have to call into diagnostic. So that's roughly the pattern. So with that, I'm going to remove that. Otherwise, this test will never do anything because it'll error every time. So now let's see. So that's one way. The into diagnostic. That's one way we can let's see handle or use miette. And you saw that pretty printed output and everything. So what if we wanted to take this, let's say, regular result of this type, and add some more information into it? Let's say I wanted to add more meaningful errors, and I wanted to chain like a sequence of errors. So basically, imagine there's like a stack of errors, and I want to push a whole bunch of other errors into the stack, and then we can unwind the stack or examine the stack when we have a reference to this error. So in order to do that, what I can do is I can say transform this error result into a miette result, and that will be a miette result with an u32. And so this essentially is, we already saw the use of into diagnostic. So this basically converts this error result into a miette result. We can go further though. So now I can say, I can add some context, and the context is something like let's see, you can have strings. So you can say foo bar baz. So this means that like, let's see, let me show you what this looks like. So we can say, actually, let's print this. So let's assert a few things. So this is an error for sure. So we can say assert, and then let's see what this actually looks like. So remember, we were using the fancy what do you call that? Cross-term stylize. So this is what enables the colors to be done. So essentially, I can print the output. I can say like debug output. I can make that blue and bold, and then the new miette result, which is whatever's in here, we can see what it looks like actually. So let's run it. So there you go. So essentially, what's happened is that originally when we ran it, we saw invalid digit found in string. This is the parsent error. This is the underlying error, the source error, if you will. And then I added another piece of information on top of it called context. And so in the report, whatever is pushed in first gets displayed last. So this underlying error will be displayed last as the root cause, and then it'll say that, okay, foo bar baz happened, and it's because of this thing. And we can just kind of like keep going actually. So there's context. We can also let's say decorate this error with even more information. So I can say, okay, there's a macro called miette, and here I can say something like custom string error message, and that should also work. So if I run it now, you'll see it goes, and again, as I'm adding, like this got added first, this got added second, and this got added third, and so when it displays it, it flips it. So whatever got added last gets shown first. So it's saying customer string error, which is caused by this, which may be, and probably caused by that. So that's kind of like how this comes out, the opposite order in which you put it in. So we can actually keep going. So I can add context, which is just essentially a string. I can add an error, and I can convert a string into an error using this miette macro, which is super handy. This is all conveniences so that we don't have to like sweat a lot of do a lot of hard work just to get nice error handling. It makes it so we can have nice things. So let's do this. So what is this? This is the standard IO's. It's a standard error, basically a standard IO error, and it's just like this thing. And so I'm this one, IO error. So basically, I'm wrapping another error in this, and so when you print it, as you can see, it goes entity not found, which is pretty cool. This is that entity not found. So if you look in here, that's what this is. Then we can add more errors. So that was like a error from the standard library, but remember we just made a new error here called underlying database error. I can do something like that, database corrupted. Notice that it says the database is corrupted here. What will happen is when I run this, just say database corrupted, too many words, database corrupted, and then when we run this, we'll see database corrupted. So that's the custom error, if you will, that was declared in this module that's being used here, and because there was an annotation with hashtag error, this error handled it, and it was used with miette. So it's pretty awesome. And then finally, we can also just wrap a plain string. So if we don't want to do anything fancy, we can just say, let's see, Halloween, what is this? Pumpkin? It's not working. Use this emoji. So this is additional context about there's some random text that I'm just coming up with. So here, so whatever I put in there, this is additional context about the failure. That's the first message, that's the second message, and so on. So it's the display, the report is inverted. So that's how that works. So now let's see, we can also let's see, we can also get the given the miette result, we can do something like this. This is like, let's say that I wanted to get there's a miette report that's contained in the miette result. So basically I can do something like this. So if there's an error, I can get a reference to the miette report, and then can do like something like that. So when I run it, so that's the miette report. I mean, given how I just turned into a string, that's the thing that essentially this first part of it. And this is the formatter, which the default miette formatter, which does this, which we're not using in this case. But anyway, this is just like we can extract the miette report, and report itself has a whole host of functions that you can call on it. Like, there's a lot going on in there. We're not going to get into that too much, but yeah, feel free to explore this. There's a whole bunch of stuff in there. So let's see. One thing I did want to show is that the miette report that we have, this thing, remember like when we ran it, it only showed this first, let's say in the stack of errors, it just basically showed just one item from it. What about the rest? How do we get these? The way we can get these is the following. We can say something like, let's get a mutable iterator for the let's see, chain. So this one actually, what this does is it allows us to get a chain, which is an iterator that will allow us to essentially walk through every single one of these items in this stack of errors, so chain of errors. So let's get the first one. So the first one is going to be something like, we can say assert equal something like that. Next unwrap to string foobar. It's not going to be foobar baz. The first thing is going to be this one. Well, if we left it in there, this test would fail, but we can try this. Let's see. There you go. it worked. So I'm going to comment this out because this is not very meaningful, because it's only showing you this additional context about the failure. But if you notice, when we iterate over it, this assertion passes, because the first thing we get from this chain is the last thing we put in it, and the last thing we'll get from the chain is the first thing we put in it. So that's kind of like, so you can kind of see like at every step along the way, like what's actually being pulled out of this. So let's see. So the next thing that we get is probably going to be let's see, this one, underlying database error, database corrupted, and that and the message is this, because again, that's how we wired it up using the this error crate. So now when I run this, that should work. There you go. Test is okay. So if we mess it up, like let's say we leave it the way it is, it'll literally tell us what the correct answer is. So it's saying, oh, and this is where that this one, pretty assertions, comes in. So we can do pretty assertions instead of just asserted queue, and then now when we run it, it'll be much nicer. So as you can see, the left is database corrupted and the right is custom string error. And we know that because it's supposed to be database corrupted, not custom string error. So there you go. Oops, database corrupted. Yeah, there we go. Okay, and then let's go the third one. Hopefully Copilot will be able to handle this. It's not handling it. I don't think that's right. I think it's not custom string error. It's actually this not found thing. So that is going to be, I think when we displayed it was like entity not found or something. Entity, let's see if this works. Entity not found. Yes, so there it is, entity not found. So basically now the next one is going to be database corrupted, and the last one is going to be this, whatever that sentence is. So let's continue. The fourth item in the chain is that right? Custom string error. I think this is correct. Yes, custom string error. Let's run it to see that works. It should work. Okay, excellent. And then we can do fifth, pretty assertions. Is that foobar baz? Yes. And then let's just do sixth and final. Let's see. And this is going to be the actual original error, which was the parseInt error. There you go. So that's essentially how that works. So this one, that is, so basically when we just did toString, it just grabbed the first one in the stack, but actually there's like a whole bunch in that chain. And so if you wanted, you could examine the chain this way, which is really nice. So now let's see. Remember we talked a little bit about box din error or din error. See if we can write a function where we convert. Let's see, we say convert the miette report into an error. I mean, we've already done this actually, but this is just being redundant. Do result, not the miette result, but the standard library result. And here we're going to say box din standard error and then error trait. There we go. So here okay. So let's see what we will do. Actually, let's put a little okay to make the compiler happy for now. And then, so let's make a miette result. That's going to be just, calling the this thing gives us a miette result, and the type of that is, how do I explicitly put in the type? It's going to be that type. So I can actually, I wonder if I can just, oh, double clicking that actually, that's very, very handy feature. Just double clicking that little inlay hint prompted VS Code to actually type that, explicitly type, put the type in there. So now what we do with the return error result is we can turn into a diagnostic and then add more stuff to it, so to speak. So then we can do wrap error, and we can say miette report, and these are all just different ways. Like you can use a macro for this, but this is just different ways. Parse int error, and I think that should do it. Oh, that's not right. Oops. Because we did the into diagnostics, so this is also not right. There we go. Okay, so what this is saying is that I'm going to convert this regular result into a miette result, and then I'm going to add this thing, this miette report message into its chain of errors. So that gives us like sort of a, we took an like a normal result, turned it into a miette result, and then added a bunch of stuff to it, which we did up here. That's nothing new. It's just a slightly different way of doing it with this expression. So now we can say converted result. So let's say we wanna do that boxed in thing. So we can say something like that. So what this does is that it goes, all right, I want to take the miette result and turn it into a quote-unquote regular result, which has the OK type is U32 and the error type is anything that implements the error trait, and that is boxed. And then we can basically take the miette result that we get. If it's if it has an error in it, we take the report out of it, and then we just tell miette to turn it into. It's super handy. So basically it just takes care of it, and we get one of these out. And then another variant of this, actually, if you wanted to see this written out with a great deal of verbosity, this is another way of doing it, where we actually we can do both. Let's see this. We would have to converted result, miette result map. Oh. So you could do something like something. Oh, it doesn't support clone. Okay, never mind. So we can. That's basically what that's doing. Is it's taking the result, and then if it's a report, then it's making an error, a type, which is this is oops. Let's call it. Actually, yeah, boxed error. And so we have a boxed error, and then that essentially converts it into that. So it's super super flexible. Miette is a really nice crate, because it kind of handles all the things that you would want to do anyway. Let's see, boxed error, and then finally we can print this to the screen to see what it looks like. I mean, this is nothing new. We've already seen it before. There it is, wrapper for the source, and then that's the thing that this thing that we added with the wrap error. That's getting shown first, and then the underlying or the root cause is shown last. So, and this chain only has 2 items in it, so it's pretty straightforward. And finally, we can assert that basically this converted result is an error. There you go. So that's an example of, actually, did that work? Let's see. Yes. So 1 test passed. It's all good. So this essentially is a sort of a more rudimentary examples, just showing how to use miette in a relatively straightforward way to get started in existing code without actually having to spend a great deal of effort making custom errors, because we used a lot of strings and existing errors and different variants of being able to create these errors out of strings. So you can use the macro, you can do it this way, and then you can even convert those things into a regular result, or you can take a regular result, call into diagnostic, and turn it into a miette result. So that's pretty cool. You can go both ways. So with that, let's do another thing. Now let's do CFG test. We'll make another module. This one is going to be a little bit, we're going to do, this is more extensive basically. This one was more simplistic, I would say. So let's do, instead of a simple miette use case, we'll do pubmod complex miette usage. Complex in the sense that we're going to make our own error. We're going to call it kvstore error, and it's going to be built on top of this error. I don't know if you remember, let's see, at the start of the video we created this other error. That is weird. Why is there, let me reload this window. Okay, so at the start we created a different error called underlying database error with the this error crate. It was an enum and just has one variant, nothing interesting. So now we're going to build a different error which uses this underlying. That's why I put the word underlying in there. So is built on top of that one. So here we're going to go a little bit more in depth into this error and also the miette diagnostic trait. So so this expression just says, all right, give this to this error, and also you'll see, like, implement the diagnostic trait for this error. So we need a couple of variants before. So let's say this is some made-up error. So let's say that we have an error where, let's say when you use a key value store or like an embedded database or something like SQLite, you have to create a folder where the persistence engine writes files that represent the KV store or the SQLite database or embedded database basically. So let's say we can't do that. Something happened. We don't have the permissions or who knows what. So we can say, okay, could not create the database folder, and it'll say for this particular path, this is all made up. So this is just saying that, okay, whatever, this is a variant where I'm saying that if the error can happen because for whatever reason couldn't create this path on disk. So let's say that I want to, remember I said this error and miette diagnostic. So let's handle this error first. I need to decorate this further. This is not, we're not done yet. So we can say error, and this error, if you remember from this error, it's used to implement the display trait. And so we can say something quite fancy. We can say something like could not create database folder on disk, which is cool. And then this is where, remember, the diagnostic trait extends the error trait and adds a whole bunch of things like code, help, URL, source code, and all that kind of stuff. This is where those fields get fed in, so to speak. So here we can say diagnostic, and here so basically it's like a bunch of key value pairs. So we can say the code and this is made up, whatever you say here, my error code, file system error. This is just whatever. It's just whatever you put in here. We'll see in a minute. This will actually be displayed in the miette error report, which is really cool. So this could be like code is like 404 or some kind of thing that makes sense in the context of your system. Then you can also provide a link actually. So this is just like a random link. So you can say, okay, display this as part of the error message, which is really nice. And there's other stuff you can do, which we're not going to do. Like if this code was hosted in crates.io, we can actually say URL docs.rs, and it will give a link straight to the documentation for this, which is pretty cool. So that's a way of annotating, making your own error, making an enum, and then for each variant, you can give more information to the diagnostic attribute and the error attribute. Let's just do one more because this is getting kind of verbose. So let's say this is like some other made up error. So we're gonna say could not get or create environment or open store, whatever that means. This is just so we can exercise this thing from. And what this does is that I can say that I have an underlying database error, which is this one. Underlying database error, and then I have to import that. So then we can say environment, let's see, or open store. Okay, so there's the from, and if you read this error, there is a nice description of what this from thing does, which is listed here. A from implementation is generated for each variant containing a hash from attribute, and there you go. So that's what we're doing. Okay. And obviously this is still red because we haven't done the hash error and the hash diagnostic. So let's do those. So, and I'll give examples of how to use this in just a minute. So let's do error first because that's a bit easier. So we do something like that and then put a bunch of strings in there. Let's see, let's do something fancy. Let's do like that. I have these strings copied in a clipboard, so I don't have to type all this with the emojis. It's quite a bit of effort to find the correct emoji. So let's do diagnostic, come on, diagnostic. Oops, what the, I wonder how this works. If I can do control, I don't know how to get like partial. I don't want the whole thing, I just want like diagnostic, whatever. Diagnostic, then we do like that. And there's like a bunch of stuff like code, help, all that kind of stuff. So let's do our own code. We'll say my error code. And again, this is made up stuff. You can put whatever you want here. This is not a struct or anything. Like you can't control click this. That doesn't do anything. It's like a literal symbol that will show up in the when we see the error. Whatever, we can just put the same URL in there. And then the same kind of thing, like we could do this if this was on crates.io, which it is not. So okay, with that we got it to compile. Now okay, so that's our fancy error that we just made from scratch with all the variants, and we're using the diagnostic derived macro, and we're using this error derived macro. So now that we've made this, let's see how we can use it. So let's see. So let's do this. We can say, let us do this. Actually, this one I'm going to put another, because I like using the assertions. If you do it like this, you don't have to prefix the assert EQ with pretty assertions : : which is nice. So let's do this. I'm going to make two functions, one that returns a flat error and the other one that returns a nested error. This is the flat one, this one, and this is the nested one because it has a source which is a different error, just as an example. So let's do this. Fn, let's do return flat error, and this is going to return a miette. miette result. I kind of like writing this by hand because it kind of reminds me that this is not the standard library's result. And then here we can say, so this says, okay, return a result, which means it can be an OK variant or an error variant. Here I'm returning the error variant, and inside of that, the inner type for this error variant is going to be kv store error, could not create, let's see, could not create, is that not right? Oh, probably it. There we go. And that's the thing, that could not create, whatever the heck this is, db, could not create db folder, and then some path or whatever. And we can say toString, and this should generate an error. Now let's use it. We can say, make a test where you say fails with flat error. And this one, I am actually going to fail this this test because I want to see all these things that we put in. I want to see them printed to the console, and the simplest way to do that is to make a test that actually doesn't run. So we're going to say let result equals return flat error. That's right. Oops, I don't know what all this is. Get rid of this. Then we're going to say, okay, we know that it's going to be an error. So we can say, if let error, let's see, error. Let's say we get the error out of it. We can make an assertion saying assert, actually, what is this called? There. So we can make an assertion here saying that if we look at the debug output of this error, it should be could not create, and actually not some path to db. This one was, I think I messed it up. Let's see, this one was, I think I put temp or something. This is not correct. There we go. Okay, something like that. So let's see if this works. Yes. So what this is saying is that, okay, I call this thing, it returned an error, and then when I use the formatter to turn it, use its debug implementation to turn it into a string, that string should look like this. So that's basically what that is. So then if I run it, it runs, and we don't really see an error report. So this is how we induce the error report. We say result. And this I didn't need to do into diagnostic because we ended up using miette result throughout. That's why there was no need for into diagnostic. So that's why there's no like into diagnostic. Okay. Now when I run it, you'll see the default report, the miette report handler, which is this thing. Because we have enabled fancy, or is fancy? Look at this thing. We've enabled the fancy create, where is it? Right there. And this is why we're able to see this fancy failure, which is, check that out. The error is my error core. Oops, that's not right. My error code. And let's run it again. So it goes, okay, my error, this is my error code, and that's my error. So it goes, could not create DB folder or something on disk, and then look at, remember we put the help, we put this this thing, help, as a link. That's how it shows up. This is so cool. And then if we had used the docs, which we didn't because this is not hosted on Cresa.io, the URL docs.rs, then it would actually have a link to the source code, which is pretty awesome. So let's see, what do we have? That takes care of the flat error. And then we induced the fail so we could see the global like report handler in action. And I'll show you at the end of the video how you can make your own, or just configure the default one to make it suit your needs. So let's do this one. Let's make a new one called return nested error. So here what we're doing is we're basically creating an error, because that's a result. This is the error variant. This is like result error, right? And I don't know, that's easier to read. Result error. And then actually let's see. And then what we're doing here is that we're simply returning this variant of this higher level error that we made, that we decorated with diagnostic and this error. And then we are stuffing this other error that we made earlier today inside of it. So this is a nest, quote unquote, nested error for that reason. And there's and then so essentially there's that's what this is. It's pretty one-linerish. There's like you can even like to see this from thing, because remember the reason this works is because we have this from implementation right there. So we don't really get to see that in action here because it's all magically working. So if you wanted to see the ultra verbose version, this is the variant. This is not very verbose. This is a verbose variant. Let's see. So we can do, what do we call it? KV store? No. KV store error. So we can do this way. We can say, oops, and there we go. I don't know why this is red. Oops. Okay. So this is one way of doing it, and an even simpler way of doing it actually is this one, variant 3. We can just do this. So, you know, whatever you feel like is better. Yeah, this is probably the most, actually, who knows? I'm not sure which one is the most readable, but I like this one for understanding what's going on. So let's go with this. All right. So that's a nested error where we're actually seeing this from in action. And this from came from, where is that? There's like a hashtag from. This one. This utterance is what generated this capability. This is making it super explicit. I don't actually like this. It's too, yeah, that's cool. All right, so let's do this. So finally, we can do a test where we're going to use this thing. So we're going to call it fn fails with nested error, and it returns a miette result. So let's do this. Could not blah 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 database corrupted. That's actually right. Oh my goodness, Copilot got it right. So let's see. Yeah, so it fails because we get this my error code store, create, or access error, which is made up code that we put in the error, and he goes could not create whatever this thing, and because the database is corrupted, and here's the help information. So this is there's the nesting. So this is another example of using miette. So these examples actually conclude the hands-on coding part of today's video. What I'm going to do now is show you some real-world examples of where this ends up being used. So let's see. Let's look at this one. Let's start with something in the Rebel terminal async crate, which is here. This thing. If you go to Rebel Open Core, and I'll put links to all of this in the video, there's this Rebel terminal async crate, which uses miette. And I think it's got a function called try new. Yeah, there's a function called try new. This docs actually looks better in docs. It's made for docsrs, not GitHub. So let's see, repo. There it is. So you can see, there it is. Terminal async try new. There it is. So this is a function that returns a miette result, which wraps, that's the OK variant, is an optional terminal async. So what this means is that, it's kind of complicated. This means that calling this function might error out. And if it errors out, then you're not going to get an optional terminal async. But even if it doesn't error out, you may or may not get terminal async. And so the reason for this super complicated return type is that these are environmental constraints. So basically, this tries to create a async read line, basically, so that you can ask the user, prompt the user for input from a terminal without blocking. So it's asynchronous. Normally, when you call read line, it blocks it. And so if you have other tasks that are generating output, it'll clobber the prompt itself. This way, because it's not blocking, I actually made it such that the standard out and the standard error can be wrapped asynchronously, and there's no clobbering that happens of the prompt. So the prompt is interactive while background tasks or other tasks are generating output. So in order to kind of get that functionality working, this try new function is kind of a constructor which returns a super complicated result. And the thinking is that the reason for this is that the terminal may or may not be interactive, because the library has no control over this. If the terminal is not fully interactive, then it returns an OK variant with none inside of it, signaling there was no error per se, but it can't really do what it's supposed to do, because if the terminal is uninteractive, then basically you can't show a prompt, you can't show output, and so you might want to rethink what to do from. There can be like a branch in your code, like what to do with the terminal is uninteractive, and it can be uninteractive when you're running it in a test environment, for example, or when you're running it in a CI/CD environment, or when you've piped let's say the output of the process or the input of the process. So these are some things to keep in mind. So this is all encapsulated in this super complicated return type. So when does it error out? Well, it can error out in case, so in order for this thing to work, the terminal has to be put in something called raw mode, and that may or may not work. If it doesn't work, then that means there's an error, because essentially it has to put the terminal to raw mode, and it has to get the size of the terminal. If it can't get these two things, if it can't do these two tasks, then it can proceed. But that's considered an error condition, because it should be able to do this. So that's why there's this super complicated result, a function that returns a miette result, which actually wraps an optional type. That's what kind of like this. And you can go into detail and kind of get a sense for how this can be done. This crate has a lot of really great. I think it has a lot of really great error handling, and it's quite sophisticated too, because there's a lot of like event loops, and there's even event loops on channels, monitoring channels. And another really good one is this. I'm going to show you this now. Is this tcp-api-server project, which is in this repo, my Rust Scratch tcp-api-server repo. It's this demo I showed you right here, the tcp-api. It's just basically this is a process that has a client piece and a server piece, and it implements a full protocol for them to communicate. And it has a nice asynchronous REPL, so that you can actually run the server, then you can run the server process, you can run the client process, and the client process you can interact with the server process. So you can do like let's see. So you can do target server, and then you can run the client, and then so you can say You can, there's like history, so you can like press up and down, and you can get like do like get all, and basically it gets all the. This is connected to a database, an in-process embedded key value store, something called SLED. And so you can kind of get like what's happening here. So exit, and then yeah. So that's this project, the tcp-api-server, and there's a lot of error handling that has to happen in here. So you can check it out. It's got a lot of really good stuff for error handling, and I wanted to highlight one of them, which is this file called kvrs, and these are like key value store operations, and when they return these sophisticated results which wrap all kinds of things, because all kinds of things can go awry when dealing with this, potentially, like when you're trying to, let's say, put a key value pair into the bucket. The bucket is a thing that comes out of the store. It might fail, and there could be a variety of reasons why it fails. And then essentially this is where if you remember, there's this into diagnostic and wrap error and all this kind of stuff, like nested errors. This is where it's actually used in real world code, so you can see kind of like, you know, how this is used in real life, so to speak. So you try to get something from a bucket, you know, it might fail. If it does, then maybe elaborate further, like what happened and why, and then provide the operator a whole host of, you know, like really valuable information so that they can debug. And also with this report handler, we can customize it so it looks really good, which brings me to the report handler. So which is also, by the way, something that you see here. So if I run this, so basically I'm running the client without running a server, and it's complaining that it didn't work. And so actually I don't need to do debug client, I just noise, so I can just do this. This is a bit cleaner. There you go. It just goes, hey, error, you know, could not connect to the server. Are you sure it's up? That's a helpful message. And it's saying the underlying error, the nested error, is that, oh, okay, connection refused. OS error 111, that's the error code of the underlying error. And then it goes, ooh, if you believe this is a bug, please report it here. So all that actually happened in here. There's something called a miette, where is it? Report handler. And you can actually customize it. You can make your own, you can provide your own, or you can customize it. So here, there's something called setup default. So if you go to the main RS of this tcp-api-server, you'll see there's something called setup default miette global something, and there's something called a footer, which is just a string, which is this line. And because this terminal supports hyperlinks, it detected this to be a URL. I can just control click it and I'll just open it in my browser, which is really cool. So I've passed in just a string to this setup default miette global report handler, which is in this tcp-api-server crate, which I'll give a link to in the description of this video. Yeah, but here, this is kind of cool. It actually detects, it does quite a few things. In this hook, it checks to see what the width of the terminal is. And then it actually basically does text wrapping to make sure that whatever text output is displayed doesn't you know, clip strangely. So this is kind of a cool feature. I mean, you might want to do your own text wrapping. There's a crate called text wrap, which is really nice, which you can have like hanging indents and all that kind of stuff. Then this is saying that, okay, go ahead and wrap lines. This is saying use ANSI escape sequences, so it's all colorful. This is saying, all right, I don't care what the terminal says, just force color, use RGB colors always. This is terminal links true, that's why this is hyperlinked. Unicode true, and context lines, like all these other things are just ways to sort of give more information with the main function that essentially craps out. So if you look at the main function here, it says, okay, I return a miette result, but it doesn't really say that the OK variant is just unit, which means don't do anything if it worked fine, but if it didn't work fine and the result is an error variant, then go ahead and use this global report handler and then do all of the stuff to actually format this report, and that's how this happens. So yeah, please take there's that footer with cost chain. If you say without if you don't put this, it won't show you this like cost chain, they call it. You remember we looked at chains and cost chains at the start of the video? That's what this is. So yeah, this is just a way for you to configure the miette report handler, and you can just make your own from scratch. But this is nice because you can just take the existing one and modify it, which is far less effort. So with that brings us to a conclusion of today's video. Yeah, if you haven't already, please, if you like the style of video, please give me a thumbs up. If you like this video also, please consider subscribing to the channel. That way you'll get notified when I add new content, which I'm trying to do like once every week. So I have like other things. I think the next one I want to do is clap customization with color, because if you look at cargo, check that out. It's using color in its customization. And check this out. tcp-api-server also does the same thing. So if you're wondering how this is done, the next video is going to be all about this. I've been meaning to make this for a while, because cargo uses it. That's where I saw it, and I'm like, wow, how do you do this? So this is going to be nice for people who use clap and they want less boring output from clap itself. And then and also check out developerlife.com. This is the blog, the blog for this YouTube channel, or the YouTube channel for the blog. I'll add a tutorial for this miette video momentarily, and then I'll if you haven't already, please subscribe for the newsletter, because this way you'll know when new blog content drops. And I tend to sync the blog content and video content together, so when there's a video that comes out, I tend to have a blog post associated with it. So if you like reading, you can use this thing. If you like watching, you can use the YouTube video. And yeah, and then I'll have all these links in the description of the video. Thank you so much for watching, and you have a great day. Take care. Bye-bye.